check whether you have a present. Yes, madam. Yes, your slide is visible. The presentation is visible now.
Okay. So, before starting this topic, I would like to acknowledge the various distinguished speakers of the past sessions who have shared incredible insights on HPC from the various aspects. And I'm honored to be here for discussing about the one of the topic which lies in the technological advancement of any field, that is HPC. So today we will be discussing on emerging trends and real-world application of HPC in data science and in AI. As we are in a data-driven world, this is one of the important thing as we are, we can say, we are surrounded with the various AI and data science applications which are driven by the data, and that data is exploding at the tremendous speed. And to handle that, we need one thing, that is HPC. So I will just take you to that journey, means how HPC is connected with the data science, AI, some of its emerging trends, real world applications, the challenges, and some of the gaps, and how we can overcome that from my perspective. So let's begin. Now, this pictures you might have watching on this slide are familiar to you. First one is the Jarvis of the Iron Man, then the humanoid robot of Wiki robot of the famous TV series, that is Small Wonder, a Wally robot, right? So these are the science fictions that we have seen many years back. But this science fiction started when the rise of the since the rise of the term artificial intelligence, like when in 1950 Alan Turing coined the term artificial intelligence by asking a question, can machines think? And all this kind of science fictions that we are actually, they are not science fiction anymore. We can say we are having a chatbot, intelligent personal assistant, humanoid robot. These things are possible. But what is at the core of this intelligent system? What is driving behind this intelligent system? If we think of that, then we may find that answer is somewhere that computing power, that architecture is also lies. So this will be the outline of my today's discussion. First, I will be discussing about the introduction of the topic, understanding the overlaps of HPC, the artificial intelligence and the data science, then the importance of this convergence. Then I'll be discussing about the emerging trends in HPC, data science and AI, evolution of HPC architecture and AI. I think this is very well covered by the previous speakers, but I'll be just quickly go through that. Then HPC in the IoT and the edge computing, as it is, we can see in everywhere in our daily life, we can experience that AI anywhere. So related to that, this HPC in IoT and edge computing I'll be discussing, and some of the real world applications like in data science and in AI I'll be discussing, and the challenges. So why HPC? So if I write HPC definition, this term on Google, so I'll get 14.9K hits from Google, right? It uses like supercomputers and computer clusters to solve advanced computation problems. That's a Wikipedia definition, or the branch of computer science that concentrate on developing supercomputers and softwares to run on supercomputers. The main area of this discipline is developing parallel processing. These are the various definitions that we can see over the internet. And there are many other 14.9K minus 2 definitions. Now, if we cannot explain it simply, we can say you cannot understand it well, as this said Albert Einstein. But what we can say about this HPC in simple terms, the size, it's all about size, and the speed. Size, we can say it cannot fit on a single PC. So it means the data. So it need more than few GBs of RAM or few more GBs, hundreds of GBs of disk space to accommodate that data. It takes very long time to run on that PC. Like I'm having a laptop and I want to run certain applications on my PC, and I want to get insights from that data on my own computer. So it may take months or years, but it might take only few hours on the supercomputer. So that's all we can define in the simple terms. The machine which can accommodate this kind of large data, as well as it can process that large data in the quickest possible time. So that is, I can say, the simplest in the words about HPC. So how about the integration of this three different terms: AI, data science, and HPC? Over here, I will be also including the big data, as the data that we are going to process use in the AI or data science are generally the big data, and for those kind of data only will be required majorly the HPC. Basically to get the quicker solution to handle this kind of larger data. Artificial intelligence is basically a technique or computers solving a difficult task through the experience, or we can say observations. It's a general term that accommodates that kind of techniques. Into that, machine learning, it includes the adaptive models that learn to improve performance on the given experience. Means it learns from the experience from the given data. So that is, we can say, one task inside the artificial intelligence. There are many other categorization like artificial neural networks and deep learning, which are the another different techniques we can say that we can use in artificial intelligence, AI. Now, data science is another section which focuses on data management, visualization, and getting insights from the data. Now, over here, we are focusing on big data, which are the type of the real world data nowadays, and the techniques to deal with that. Generally, which we are getting in the real-time streams or real-time datas. And from that, we need to get the insights using some statistical techniques. And over there, we will require some technique, or we can say we need some architecture that can get this, we can say, output, visualization, or insights from that data in the quickest possible manner, in the precise manner. And for that, we will be requiring HPC. So that is how I can define this as a perfect union, that AI, data science, big data, and HPC. So before moving ahead, I would like to show you the current scenario of high performance computing, the global startup market. So over here, this is the heat map shared by Start US from the data of February 2023. Over here, we can see that global startup heat map contains a distribution of 549 startups and emerging companies that are distributed across globe, and which are on high performance computing, which are more or less using some sort of applications or in the various fields like AI, simulation and the digital twins, or scalable computing, edge computing, cloud computing, blockchains, quantum computing, distributed computing, thermal management, cybersecurity. But over here, we can see that the major portion, that is 30% of that, startups are based on AI, means the high performance computing applied to the AI applications. So we can see this convergence of AI and high performance computing is how important, and it's interesting to understand. So the importance of this convergence we can see from this, from this graph that that shares the insights of the global AI enhanced HPC market, that from 2020 to 2030, it will be increasing by 9.4%. We can say by right now in this data was collected in the 2023, so it was worth $2.6 billion, and it is to be increased by 9.5%, 9.4%. So we can see that it's quite important thing to focus over here, the convergence of HPC and AI. Sorry. So we can say in a simple terms, big data is a fuel that powers the AI model, and the HPC systems are the engine that processes that data efficiently in real time to get the interesting insights. So that is how we can say that it's not, none of the part is the complementary. Uh, we required all these things, means AI, big data, HPC systems, and data science to work in a synergy. That's why we can call it as a perfect union. So next, moving ahead to the emerging trends in the HPC and the uh, data science in the AI. So let's look at first the evolution of HPC architecture and the AI, and then we will be covering HPC and IoT in the edge computing. So over here, I'm not going into the much detail of HPC architecture, as I think this is covered very nicely in the very first session by Professor Raghunandan Mathur regarding how it is evolved from the simple CPUs to the exascale computing. But over here, we can see that the exascale barrier is broken now in the 2020. In the race is in HPC. So the frontier supercomputer, we can say, is designed to process this AI workloads for large-scale research work at the peak of 2 exaflops. So exascale, we can say that a system which is capable of performing at the speed, we can say 10 raised to 18 operations per second. So this is how we can say the HPC systems are evolved in nowadays, from we can say ambiflops to the exaflops operations. So now let's see how this high performance computing is affecting the IoT and the edge computing. Now, HPC resources, we can say, deployed closer to the data sources such as sensors and cameras and IoT devices to enable real-time analytics and the decision making. So basically, why we are talking about IoT and the edge computing, the reason is that nowadays we are surrounded with many smart system around us, like smart home system, autonomous vehicles, or many such things which are smart if we look at around us. So this smart systems gathers the data from the various sensors. This data, the sensors are generating or collecting the tremendous amounts of data. So that data we are actually not sending to the centralized servers just to reduce that latency of the processing by the data at the edge. So we need to assure the high speed computation with the limited power and the space. So we need a powerful computation, which also ensures the, we can say, the speedy computation at the edge devices, which handles this tremendous amounts of data uh, collected by the sensors every seconds, every minutes. So for that, we need the accelerator, edge with the accelerators, and those are equipped with the software environment for HPC on the edge devices. So over there, the programming models like SQL, NVIDIA CUDA, OpenCL, this kind of programming models are used, some benchmark tools are used. So this is how we can say the scenario of IoT is there or edge computing is there where we require HPC. Now, we see this IoT generates exabytes of data. So we need real-time insights for the critical applications like healthcare monitoring, autonomous systems, we can say smart infrastructure. For that, we need HPC processors, HPC devices or processors that can process that data and give the real-time actionable insights for this kind of our critical real-time applications of the AI, we can say. This is the case of where we are actually using the AI with the help of IoT and the sensors in the smart environment. So we can see what programming models are we are having for the HPC on the edge with us. This is the data that is taken or collected from this programming for HPC on the edge accelerators, this article from the 2023. They have made the review on, they have reviewed different HPC architecture on the edge devices or IoT systems. And they found that majorly this programming models are used like CUDA, OpenCL, SQL, and OpenMP for programming on the HPC on the edge devices. For that, this comparison is given like the level of expression. With the CUDA, we can say it is middle level of expression. OpenCL, it's low. For SQL, we can say its level of expression is high, and OpenMP also it's high. Uh, for supported architecture, it only supports NVIDIA's GPU. OpenCL supports the CPU, GPU, FPGA. SQL also does the same. OpenMP is also supporting CPU and the GPU. Now, if we talk about the framework for that implementation, then CUDA supports the C, C++, Fortran extension, and OpenCL supports the C and C++ extensions. SQL supports C++ extensions. OpenMP is a compiler directives. So this is how we can say these different programming models are doing for the different we can say parameters. Open for the proprietary, this all three are open source, whereas CUDA is the proprietary by the NVIDIA. The major feature we can say about all this programming model is the popularity for NVIDIA's GPU. This is CUDA we can use for the NVIDIA's GPU. Then OpenCL is for heterogeneous support systems. SQL is for single source model. OpenMP is having quite having easy programming model. It is having ease of programming. So I think this thing also you might have seen in depth in the previous sessions on the OpenMP and the CUDA. that insights are really good. Now, let's see what HPC means. What are the key technologies are used in HPC in IoT and edge computing? For the hardware, this is just an example that what kind of hardware we can use with the HPC in IoT and the edge computing. For the hardware, we can use the NVIDIA's Jetson, which is compact HPC-enabled edge devices optimized for AI workloads. Intel's Movidius, which is AI-accelerated processors for IoT devices. For software side, we can use the NVIDIA's Holoscan, a real-time streaming and AI processing framework designed for specifically edge-based HPC use cases like medical imaging or industrial IoT. Edge AI frameworks like TensorFlow Lite, PyTorch Mobile, and NVIDIA DeepStream. Edge analytics tools like Apache Kafka, Apache NiFi, and of course, for networking, we will be requiring 5G. So these are the, we can say, the technologies that we would be requiring to implement HPC in the IoT or the edge computing environment. See some use cases of HPC, IoT, and the edge computing. In the real time, this is the data we can see from the NVIDIA's Holoscan, a real-time 3D surgical guidance using pre-operative and the live data. They have created this to provide the surgeons with the real-time and the accurate guidance during minimal invasive or robotic assisted procedures. Generally, what happens when surgeons plan some this kind of major surgeries, they have some sort of 3D or 2D two-dimensional photographs or scans of like MRIs and CT scans. But at the time of surgery, they don't have access to that. And according to their understanding, they need to have some incision, and accordingly they have to do the surgeries. So to have the precision surgery, or we can say the robotic assisted procedures, we can see over here this kind of we get the support from this real-time 3D imaging. It's this we get from using this NVIDIA's Holoscan. So this is the innovation by IM Fusion, a Munich-based company, and the NVIDIA Connect program member, which use the NVIDIA's Holoscan to combine this pre-operative data with the real-time operative imaging. So by using that, the surgeon can get the guidance to have the minimal invasion during the surgery. So the system combines the AI, accelerated computing, and the advanced visualization. For this thing to fuse this to images, we can say this 3D real-time 3D guidance, we can say they need to fuse the pre-operative imaging and the live data in the real situation. So it requires the accelerated computing and the advanced visualization. So for that, NVIDIA's Holoscan has provided we can say domain-specific platform and scalable infrastructure needed for real-time processing of that streaming data at the clinical age. There are many other use cases as well, but let's see the other real-world applications of HPC in the data science and AI. So let's see what is the role of data science. Then we will go to its different applications or case studies. I must say the role of data science, I would come back to this slide, this picture once again. There's a gas station where this is my car. Let's say it's an AI model. The engine of this car is the HPC system, and the fuel is the big data. So what is the task of this data science over here? So big data fuels this data science models. Data science models basically uses the AI and the machine learning techniques for getting some exploratory data analysis or some visualization, some insights from that data. So basically this AI model, we can say the data science lies over here in my car. It uses some techniques of AI for the it involves the cleaning, processing, analyzing massive data sets to extract the actionable insights from the big data. So big data is the fuel from which the data science has to extract some actionable insights, and it applies the machine learning and the deep learning algorithm, which is powered by AI, to interpret that pattern from that big data. And it has to give some interesting predictions from that data. And data science uses the HPC system, that is the engine of this car, to perform computationally expensive operations like a training of a large model, AI model, because in the training, the accuracy or we can say the performance of any of my this intelligent systems depends on the training of that particular model. So we can say how good we can train that model. It depends on the training data. So if we are training this model on the large data, training data, so for that we require computation power, good computation power. So over there we require HPC to perform this computationally expensive operation like a training. Running that simulations or handling the complex statistical calculations for data science, we can say we are getting insights from the data. So we need to perform plenty of statistical calculations to get the insights from that data. So which requires some computationally expensive operations, statistical operations. So for that, we uses the HPC. So that's it in the summary of this role of data science. We can say this big data fuels this data science models, and AI algorithms make predictions and the decisions. And HPC, that is the engine of this car, it accelerates this entire process to get the actionable insights from this big data. So let's see the different case studies in the data science and AI. So first one we can see over here is the climate science and the Earth system modeling. So HPC helps process this kind of sensor data, which are generally in terms of terabytes and the petabytes, we can say large quantity, from the satellite images and the environmental predictions. Based on that, this climate modeling is done. So for that, the complex calculations, HPC helps for processing that complex computations as well as the processing that sensor data. Also, we can see over here this Earth system modeling example where NASA uses HPC for Earth system modeling to forecast global warming trends based on the past history. They have predicted or forecasted for the global warming trends. Now, these are the applications where we need the precision for the particular in the prediction. That's why we require the HPC system over here. Not only the speed, we also require the precision as well. So we require this kind of HPC systems to model this kind of applications. And the drug discovery and the simulation using molecular data, over here you can see HPC helps reducing the execution time for the predictive modeling. of the Monte Carlo simulation or the statistical test in the data science, which are, we can say, compute intensive in a nature. In the genomics and the bioinformatics, we can say the HPC provide the computing power to perform large-scale gene expressions experiment to analyze the resulting data. Now, in the genomics, there are various tasks, like one of that is, we can say, the genetic variant analysis. So over here, it's another area of genomics that requires HPC. So basically, the genetic variant analysis, it involves the identification of the DNA sequence between the individuals. So these variants can have significant impact on individuals' health and risk for the certain disease. To get insights from that, we need to process that, and it requires the complex processing. So it requires HPC. HPC also enables the efficiency analysis of large-scale genetic variants data in the precision medicine approach. Like based on my genetic variant analysis, I need to get some insights on what specific type of medicine or drug is applicable to me for specific kind of disease. So that kind of precision medicine approaches, this HPC is useful to get the, we can say, the interesting insights from that complex data. Another type of application I can say is the financial analysis. Like in the financial analysis, we can say the fraud detection, risk analysis, or algorithmic trading. Like in a high frequency trading or the credit or the fraud detection or other tasks in the financial analysis, it requires to observe a large set of parameters and a complex patterns which are compute intensive, which requires HPC. Also, we need to get that results in the very timely manner, also the precise manner. So it requires the HPC systems. So we can say one of the example use cases, like JP Morgan uses the thousands of NVIDIA GPUs for real-time pricing and the overnight risk estimation. For that, they use a graph-based computation for risk management at the Grasshopper and this Triton inference server. You can see that that detailed article regarding how JP Morgan has used that NVIDIA's GPUs for real-time pricing and the risk estimation using this graph-based computation thing. Another type of application of, let's say, data science or AI in the field of aircraft engine simulation. But also it requires, why we need HPC over here. Let's figure out that. Now, this kind of industrial designs, this industrial designers use fluid dynamics to optimize the airflow and enhance the vehicle speeds and efficiency at the time of simulation while designing. So this kind of things, before designing and bringing it to the practice, they need to be simulated, and this simulations are compute intensive. So for that, we require high performance computing. So over here, there's an example of this aircraft engine simulation for first full engine computation with this particular simulation, for which they have used Joylot Curie supercomputer for building this, doing this simulation of this aircraft engine. So we can see over here the various applications of data science and AI from in the various diverse field, where the complexity or the compute intensity is there. We require the HPC system. So we can say that the data science and AI is there and we need to grow in that field to touch the many of the applications. We need to have help of that HPC architecture. Another type of example is like training a deep learning or machine learning models over large data set. So over here we can see training AI models like a GPT, generative uh, pre-trained models, generative models, AI models, which involves the analyzing the terabytes and we can say petabytes of textual data, of big data. Okay.
Madam, any problem?
Actually, I was looking at the chat.
Okay.
Okay, I'll be just taking those things at the end. Okay, so the training this kind of AI models or the machine learning or deep learning models, which requires a larger, which need to process the larger data sets in the terabytes or petabytes, which cannot even accommodate into the single system or single storage. So that data is distributed across, we can say, the multiple nodes and requires distributed processing. Then also the optimized model training is required with the GPUs and TPUs for the faster computation. So at that time, HPC is used to train that model from the massive amount of data in the fastest and the effective manner for the various applications. We can train the model, the machine learning model, but it depends. Thank you so much, sir. But it depends, we can say, what type of training we are providing. Means the quality of the training, depending on the quality of the training, we are getting the answers from the model. Just like we have taught a kid to the ABCD in the proper way and taught another kid or the same kid ABCD not proper way, then we can see the difference, how they are means reflecting while encountered in the real-time situation or unseen situation. So same way over here, we need to teach a model, a machine learning or a deep learning or AI system to, we can say, answer on or some unseen circumstances in the precise manner. But for that, our training need to be the perfect. So for that, we need that precise training. Of course, there are many parameters are affecting that. But yes, that to handle that large data, considering that we are providing the precise training in terms of enormous amount of properly curated data, but to process that enormous amount of data, it requires lots of time if we are not using HPC. So to reduce that data, so the processing time and to process that data effectively for this training that model, we require HPC. So what are the challenges of using this HPC in the AI and data science applications or this field? Let's see the scalability and the cost, the high cost of infrastructure and the maintenance limits accessibility. So for that, we can say the cloud-based HPC service offers scalable like pay-as-you-go models. For here, we can say many of these companies like AWS or IBM, they are offering, and many others are offering this kind of cloud-based HPC services for also the Microsoft Azure for pay-as-you-go models. Means we don't need to set up for the small scale things, I'm talking about the small scale things. We don't need to set up our own infrastructure. We can choose for this kind of cloud-based HPC services. How about the data security and the privacy? We can say large-scale data storage. And yes, that computation pose the risk of that data security and the privacy while working with that. So for that, we can say we can apply the federated learning and we can say secure multi-party computation. That's a totally, we can say, another point of detailed discussion on this data security and privacy while considering this HPC use cases. But that is that we can say we can solve using federated learning and the secure multi-party computation. Another major challenge I just feel that is the skill gap. For, let's say, we just seen now how HPC is important to scale the AI data science applications. Means I need to means I need to grow in the market with the AI and the data science applications. For that, I need to process enormous amount of data, and for that, of course, I will require that HPC architecture. I need to work closely with the HPC, AI, and data science. But for that, we require the specialized training in the HPC programming model. These are just a few, like MPI, OpenMP, CUDA. I think you all have gone through that in very detail from the very nice speakers like Dr. Vamsi Krishna, Om Chadav. They have really given nice insights on all these things. But yes, there's a skill gap which we require to fill to get, we can say, onto that HPC applications. So what we can say, what can be the solution? How we can address this skill gap and integrate that parallel programming. So how I did this is the insights that I'm sharing, that how I did and what I feel. Let's say training, we can say specialized course on MPI, OpenMP, CUDA, and other the HPC things can be provided on the NPTEL, Coursera, edX. And I think that is very nice initiative by the ATAL as well to provide this kind of training, short-term training on this kind of topics that you can explore later on. Of course, some of the NPTEL courses are also there that we can explore. There should be the collaboration like industry academia partnership and for the real world projects that can spark the interest in this field to the we can say the many audience or the students or the people. The tools and the open source repositories and the optimization tools should be developed. Just in a previous session only, I'm so glad to say that Dr. Vamshi Krishna sir has also shown that the GitHub repository regarding how we can use the CUDA programs to learn about CUDA, the various courses and his resources on that. So that kind of tools and open source repositories should grow to fill this skill gap. Another indirect way to introduce this parallel programming in the is the, we can say, the core subjects in that we can introduce. This is what I did over here in my university. But actually, we are having the flexibility to introduce some of the topics of the parallel programming into the core subjects. If we cannot introduce a whole subject of OpenMP or CUDA or MPI or any of the topic on the parallel programming, but yes, there is a still room to accommodate this parallel programming or HPC basics things to our core subjects of the computer science, like data structures, or design and analysis of algorithms, or we can say any programming subjects, like in a data structures. In just my UG students, I just provided them with the basic of the OpenMP. We can say, yes, we are having one question. Do you have something in curriculum? Actually, no. Over here, we are not having, means we have to decide our curriculums. So, in our curriculum of data structures, from the using even with the standard data structure topics, I included the parallel programming basics in different topics, like in a sorting algorithm. Suppose I'm teaching the sorting algorithms in one module. So along with that simple sorting algorithms, I'll be teaching how to parallelize that algorithms. Like after teaching that merge sort, or let's say the bubble sort, or different sorting algorithms, I'll be teaching how we can parallelize this sorting algorithms. And I just ask the student to observe the effect of the parallelization versus that serial algorithms. So that sparks the interest into the students, how they can be introduced to the this parallel programming in the simplest possible manner. Along with that, not a specialized subject, but with that core subject only. So that is possible. Also with the algorithm subject, I introduced the same OpenMP and the MPI for different topics, like dynamic programming or different matrix operations, divide and conquer. Means certain topics where we can compare the sequential processing with the parallel processing in particular scenario. So for all that things, we can at all that things we can introduce OpenMP, MPI, or even a simplest of the parallel programming basics. And yes, the hands-on experience or the project that we can give, on the OpenMP or MPI, to solve the real-world problems. And for my surprise, this time I got very nice results with this experiment with the students, whom I given just taught some basics of OpenMP and the MPI, and I asked them to make a small project on that, which involves some, we can say, the real world application. They have to take a real world problems from any of the live problems available on the Kaggle, or many websites are there. So from there, they have to pick that and then just solve it using some data structure concepts that they have learned in the course, so that they get evaluated on the data structure or the design and analysis of algorithm course as well. And they have to include the parallel programming. So this is how they get the fun way, the insights on the parallel programming, along with the core subjects, without having burden of learning something new. So this is what I do. We can do such things to we can say introduce this parallel programming to the students. Students gain the practical parallel programming skills with their enhanced understanding of the core subject. That is what I found by applying this solution for this skill gap. So at the end, what we can say about the future of HPC, AI, and data science. So I would like to focus on this, some of the key projections, like on AI-driven HPC systems. That is, by 2035, AI-driven HPC systems are predicted to power over 75% of all scientific simulations. So we can see over here, by 2035, it is it means we cannot think of anything, any AI system or any intelligence system to work well without HPC. So we can see how important it is. So, and that data is from the National Academics of Science, Engineering and Medicines. That is Frontiers in High Performance Computing for Health, published in the 2020. And we can say from the current scenario, how true it is. Market growth regarding that, I can say the global AI and the data science market is expected to reach 1 trillion by 2030, with the 60% of that driven by HPC enabled innovations. So from this insight also, we can see that it's a good to have the skills in HPC that can drive the innovations in the AI and the data science. I can say it's not only drive, it just fueled up the innovations in the AI and the data science in for our real time or real world applications of the day by day. Data explosion and the transformative potential regarding that, we can say that data generation is projected to reach 175 zettabytes by 2025, necessitating the real-time processing by HPC systems. And this is predicted by the international data corporations. From all this, the main idea behind this key projection to tell you that it's necessary to have some insights on how HPC is important to even to drive the innovations in AI and data science for our real world applications of the future, or we can say of present, even present. So HPC is no longer be limited to the scientific domains now. Its application will touch each and every field. So for that, we need to work on how we can converge on HPC, AI, and data science with all possible manners, and how we can, let's say, encourage the students to gain insights on that. That's it from my side.
Participants, do you have any questions? Yeah, you can post questions here. What about the Python parallel programming? Is one question from Dr. Bino VP.
What about Python parallel programming? Python parallel programming. Actually, Python is, we can say, a wrapper language. Mainly, we are HPC systems, we can say, are working closely with the hardware, where we need to closely work with the memories and GPUs, where this languages like C, C++, Fortran, or with the GPU, specific GPUs, we can say the CUDA are more specifically used. Python is we can say, the wrapper language, or we can say the application or high level language. So for this processor level, the parallelization, we would require to have, that's why I said the skill gaps means we need to have inside. Python is very much famous, or we can say popular for the AI and data science applications. They are popular for the applications, but for want to deploy those applications on the HPC systems, we need to work closely with the memory and the parallel, means how they will interact for that hardware, for that C, C++, Fortran, this kind of languages, or the this OpenMP, MPI, these concepts, these are required. I hope I answered your question.
Yes. So what do you have something in curriculum? You have already addressed it. Yep, I think.
Okay. Okay. If you want to see the curriculum, my current curriculum, then share that. Means how I included this parallel processing, basics of parallel processing in my current subjects. Actually, over here we are having flexibility to include or any topic, introduce any topic within a particular subject. So accordingly, in the data structures, I'll be just sharing you this my syllabus that I was currently teaching. That is data structures. Yeah, here it is. So, okay, let me share my screen once again. Where's the share option? Okay. Okay, I'm not able to share this.
It's okay, madam. Then you can share the document with me. I'll in turn share with the participants.
Okay, fine. Actually, that's the syllabus of my current subject. That's it. And over in that, if you can see, just in a few of the topics, I have included the parallel and the distributed programming or the real world applications. Over here, we used to have different evaluation components as well, apart from the classical exams, like using projects or active learning assignments. We used to evaluate those things. So I actually designed this parallel and distributed programming topics such a way that they are evaluated on active learning assignments and the project implementations.
Yeah. So that's really useful, madam.
Thank you, sir.
Yeah.
I'll be sharing that.
Yeah. Yes.
Parallelization in the ML algorithms. Parallelization in the ML algorithms